Hi, I'm Caesar. In today's videos, I would like to make a simple demo or tutorial about how to use MSC Adams. MSC Adams or Adams is very well-known software for the multi-body dynamics. It is widely used in the industries such as automotive and machinery, and it is maybe like one of the first software in multi-body dynamics because it is very well known because of its robustness to solve some machineries problem. It has a lot of templates for machineries, and it is very like less computational effort. If you assembly like very complex machinery, Adam can solve it with low computational hardware requirements. And for the Adams itself, the Adams view is like the classic version of the Adams. If you want to more user-friendly Adams version, you can download and install the Adams modeler. But maybe it is not as powerful as the Adams view in terms of the completeness of the like the templates or anything like that. But the good news is you can connect the Adams model to the Adams view. So Adams view is more classical, I can say. For example, you must sometimes input the coordinates or anything like that. But it's no problem if you are very professional, like pro user of CAE or CAM and CAE. It will be easy for you. So let's wait for our Adams to open. And here we are, the Adams user interface, Adams view. Very classical, but it's very powerful if you want to do some series works. So just create a new model and just like set your own directory to save your model. I will use these units. The gravity maybe like I can ignore it because in this video I would like to make a simple crankshaft tutorial, crankshaft, piston, and connecting rod mechanism. Actually, you can model your geometry here, like to make the connectors and balls, box maybe, and anything like that. But maybe nowadays the CAD software is already well established, so maybe it will be rarely used now. So we just import our model. We can import various extensions such as the I guess step, or maybe here I will use the Parasolid or XT. To import the model, just right click in the file tree and click browse. I already prepared the geometry. If you want to have this, I will maybe provide the link in the description, or you can check my website on the pttensor.com. You can request the geometry. But please note that the geometry you export, if in the assembly, should be like separated, or like not in the one model or not in the one part but different bodies, but you like have to make it like the assembly part, assembly by its part separated, so it will be easy to read here as the different parts. Let's say we want to give the name piston assembly. Okay, it is actually already imported, but to refresh the to refresh this display, we sometimes have to change the model and go back again. So this is our model. The control, you can use the T, press T, and then click in the screen. You will see like to pen move this, then using the R to rotate it, and the Z to zoom in and zoom out. So that's 3 basics controls, or you can use this menu to select the control. Okay, let's change the display. Let's say I want to display it like the shaded or maybe precision shaded, but it's not necessary here. I think this is our model. Then this parts should be separated like this, so that's why you must keep in mind that if you want to if you want to export from your CAD program to import here, you must make the parts separable. Okay, let's go to define the connections. Before that, we must make the reference points by using the coordinates. I already prepared the coordinates. You must check it from your CAD modeler. Unfortunately, we cannot automatically detect from here. If you want more convenient way, you can use the Adams modeler, but it is not that hard. Let's just make the coordinates. So the function of coordinates is to connect between the parts. Let's say the piston and the connecting rod. We want to make the marker here. So you just click the bodies, construction, and click the marker. And we want to add it to our part. So just click to add part. Select the piston solid one. And you can arbitrarily select the coordinate here, but we don't want to make it arbitrary, so just right click and we input the coordinate manually. So we want to make this point, so it will be minus 43.6 millimeter in the X direction. In the Y direction, it will be 1.63.0. So it will be like this, depends on your coordinate system. And we can apply. So it will belong to the piston. So I will rename it. Let's say piston TP to crankshaft TS. Connecting rod CR. Okay, because we make the constructor at two parts, so it will be moved with the piston. So if the piston moving, the marker will be also moving, so it will not locked in this coordinate. Okay, let's go to the next marker, which is here. I will make it belong to the connecting rod and right click again to input the coordinate. The X will be 73.89. The Y coordinate will be 134.41 and 0. Apply. Oh, wait a minute. Oh, it should be negative Y. Okay, just double click in this marker and you can edit it directly. I will rename it as connecting rod to the crankshaft. Okay, the last one, I want to make the, like the connection between the crankshaft to the ground, or maybe if you have engine or anything like gears or anything like that, but it will be imaginary, so we'll connect it to the ground. Marker, connect crankshaft, right click again, and we input the coordinates. The X will be 41.7 minus 166.63. Okay. Oh, sorry, it is minus X again. I always make these mistakes. Okay, and it will be, I will rename it like the connecting rod to the ground. Okay, maybe you think it is like a bit tedious and maybe like complex compared to, you know, like other software, but it is maybe one of the powerful thing to describe the more customized, and it is, you know, like it is like purely kinematic, so it will be more or less use the computer resource, so it will be like easier to run and more robust because of this simple definitions or simple connections. Okay, let's go to the next step. We will describe our connector. So let's say I want to revolve this connecting rod to the ground. It means like it will be fixed there in the X, Y, and Z translation and only in one rotational direction. So we will use this revolve joint. If you want to explore the other, let's say this spherical joint, it will just have different degrees of freedom. So the revolve joint, it will be locked in XYZ translation and only rotate in one particular direction. So to select this, you just click this and click the first body, which is crankshaft, and click the second body or second entities, which is ground. And thirdly, you define the location. So we already renamed the point like CR and GR. So you can search this like this or doing the right click. So it will pop up the selections or maybe the option that's maybe around here. Okay, so this is our revolve joint. We make another one for the crankshaft and the connecting rod, and we click the point CRCS. That's our second one, and the last revolve will be for the connecting rod to the piston at the PTCR. Okay, here we go. We already have the revolve joint, and again, maybe I will describe or I will lock the degree of freedom of the translation of this piston to only in the Y direction. So I will use this translational joint. I will connect between the piston and the ground, and I will select the PTCR again as the point reference, but it will be we must click once more for the direction, so we must search for the PTCR Y. So it will be on to the Y direction. Okay, so be careful to use this translation because you should click one for the body, a second for the second body, third for the reference point, and fourth to the direction. Okay, next we design the motions. Let's say I want to make the rotational motions using this joint motions. So I will set the rotational speed, let's say 30. I will explain it later. Just click to this joint one, so we'll rotate it like this. Let's check the setup. So you have three types of inputs, which are the displacement, velocity, and acceleration. Velocity is like angular velocity, and acceleration is like the angular acceleration. And for the displacement, the D here is the degree, so it will be like 30 degree times time. So it will, in 1 second, it will move like 30 degree. If you want faster, you just change this value, or if you want to like the velocity changing with time, you can input the velocity, let's say on let's say velocity 1 degree times time, so it will be like 1 degree. It will be changed with time, but I will use displacement for more easier to explain. And I want to make it more interesting, I want to input the force. Let's say force, it will be, let's say 100 Newton. So the unit here will be follows as the first we set at the first definition. It will be body moving, so if the body is moving, the like the force will be also moving. So I will select the body here, the piston, and select the application, which is in the PTCR marker, and select the direction will be on the Y direction. Oops, sorry, it is not here. I will delete this. Let's redefine it. Okay, select the piston and PTCR and PTCR Y. Okay, so it will be in the Y direction. Maybe I will make the force negative because like intuitively we will expect that the force will be in the minus Y direction. Of course, you can also make the function of the force. Let's say if you want to make some equations here, this is one. Maybe this is why Adams is very powerful, because you can customly make your own equations, or maybe you can connect it with Cradle CFD if you want to make the real explosion. But in this simple tutorial, I will use just the constant amount of force. Okay, I think that's all. Let's just run our simulation by using this simulation and using this gear. I want to check the start at equilibrium and reset, so it will be always reset before running. Just click this and it will be moved like this. So it is 5 seconds, or yeah, it is 5 seconds, and our motion is 30 degrees times time, so it will be like 5 times 30 degrees moving. So I want to make it like 1 second. Let's say it will be moved like only 30 degree. So if we want to move like 360 degree, just 360 divided by 30, it's like 12. Yeah, and if you want a smoother moving, you just increase these steps. Okay, let's say I want to make the graph of this motion. You just click this or plotting. Okay, in this plotting, it is also powerful because we have a lot of parameters to be displayed here. Let's say I want to check the constant one, the joint one. I want to check the total torque. Or maybe not this one. Maybe connecting rod. Or maybe the motion one. I want to check the torque. So you can check the torque needed to move the piston, and also the power consumption. Let's say I want to use surf just to make it edit direct, like change it directly. You can check the consumption of the power, or maybe it is very useful if you want to design like the bearing. You can also use the bearings and anything like that. And the velocity, angular velocity is constant, like 30 degrees per second. Like we like our definition, 30 times d times time. So the acceleration, velocity, and you can also check the other bodies. Let's say in the piston, the acceleration of the piston, the velocity of the piston, the position, it will be like this. And I think you can explore everything you like or you need here. Wait, I will check also the force maybe. Okay, That's okay, you can explore it. And we can also make the display like side by side here. Oops, sorry. By right clicking this one and make the two views like here, like this. And this view, maybe I will input the animation, so you can set your position and you can make cool animation like this alongside with the graph. I think that's all. You can explore by yourself. It is very powerful software and become standard in the industry, so I really highly suggest you to use this tutorial. And maybe in the next tutorial or the other videos, I will also discuss more about the mechanism, like to how to make the gears and maybe the chains, bearings, and anything related to machineries. So just please subscribe to this channel and please comment if you have any questions or maybe some requests. I hope I can help you in the other video. Thank you for watching. I hope you enjoyed this video. See you in the next video.